What's going on, guys? So I'm back, episode 2 of this cross-cart build. So I've actually got, you saw in the last episode where I modeled up some things in Fusion 360, putting together a plan for this this unique rear axle, rear drive setup. So I've got the first parts for that ready to go. I've got my material. I've got some 7-inch round, solid steel round bar, if you want to call it, billet. I've got that in the shop. I've cut 2 pieces on the bandsaw. So I actually filmed all this, cutting it on the bandsaw, getting it roughed out in the lathe, and my SD card had an error or something, so I lost all that footage. So anyway, I've got those pieces cut on the bandsaw. I chucked them in the lathe. My stock is 7 inches. The OD of my part is 6 3/8. So I roughed out, I threw them in the lathe, squared them all up, and got them all roughed in the lathe down to 6.5. So we got those 2 slugs basically ready to go. Next step is going to be to throw them in the mill, and then we can kind of start to rough them out. So that's the plan. So let me bring you inside and kind of show you what I've got going on. So you can see my 7-inch billet here, and then I put them in the lathe. Filled the lathe up full of chips here. But anyway, so we've got our billets here to work from, and then I've got this one already in the mill here. So I've got my super spacer here, so I'm using that to hold the stock. So very handy. The super spacer is super handy for holding a round thing, in the mill. So that's what I'm doing. I'm gonna get my tools set up, get my work offsets all ready to go, kind of load up some tool paths into the machine, and start making some parts. So before I start going here, I thought I'd just kind of show you guys a little bit what I got going on here. So that would be the left. This is the center of the cart here. Inner pivots, outer pivots. There's the upright, or spindle, or hub, however you guys wanna. In the racing world, they call that an upright. So there's the upper pivot, lower pivot, and then on this side is the toe link. So that keeps it from steering on the rear. So then up inside here, you have your CV, and then and then that CV rides inside of the wheel adapter. So let's deconstruct this here. All right, so there we have it. That's the part we're making first. So basically, wheel bearings ride on this. CV's up inside. Then you have your wheel studs, go in those holes. You flip it around, wheel pilot, So anyway, sounds fun to me. You probably saw there in the time lapse me moving around doing stuff. So we've got the tool paths all figured out here. We got a facing op. I'm gonna face it. And then I'm gonna do a little pre-drill here just to help with the when I start roughing out this center. It's doing a helical plunge here, but it's a little bit of work for the end mill to do that. So I pre-drilled it, so it'll kind of have a place for the chips to go and just kind of give it a little relief. So you're gonna do a 3D adaptive clearing, and then just multiple different contours to clean up all the faces. Then we have a scallop tool path, like a surfacing tool path to do the chamfer and the fillet here. And then we're gonna bore the holes here, and then a chamfer for the edges. One thing I just thought about, I probably should drill the holes here as well while I have it flipped here, but anyway, there we go. So it's a pretty long run time on this part. I'm gonna do it kind of slow, a couple hour run time. So next step is I've got all the files and everything plugged into the CalMotion little USB drip feed controller here. So we'll drip feed it to the to the Fadal and get this thing cut. So one more thing, I do need to check my coolant in the back, but it is, it's a little bit of a process to machine parts. It's not like I probably have 3 hours just getting this thing set up, getting all my tools in, tools loaded, work offsets, fixture offsets. Making one part in the mill you know, it still takes some time. So, but once you get it set up, then you're good. Here, let's see what we got here for coolant. Yeah, I could add a little bit of, probably add a little coolant to it. But anyway, that's where we're at. So next time I check in with you, this thing should be running, and then we'll see how it's going. All right, there we go, guys. First off, facing the part. I'm not used to cutting steel. I cut up a lot of aluminum, so I'm used to feeds and speeds for aluminum and kind of what you can do, how hard you can push it. But steel's like kind of another animal, so I'm having to kind of relearn how to cut steel, basically. I tried to run the program once, and I think I was just trying to take too much of a step down, and then I also changed out the inserts in the shell mill. So anyway, it's a learning. It's always learning. So working through this part here, making some changes. It's kind of the nature of it. I started machining it. Everything was going pretty good. I realized, I thought I had it set correctly, but I realized that my depth of cut was going to be more than my depth of cut on the end mill. So I'm going back and adjusting a few things, waiting for the adaptive tool path to recalculate. So, you know, I'd rather play it safe, go slow, than wreck a $300 end mill. So that's what I'm doing, kind of just making my tweaks. Other than that, though, everything's looking good. I got a pretty good hole going, and the end mill's happy. Like I said before, I've cut a lot of aluminum, but I haven't cut a lot of steel, so it's definitely a little bit of a learning curve. All right, so we're doing our second op, faced it, now we're roughing it. Got it running pretty good, nice and quiet. Running about 2,000 RPM. I don't know, about 20 inches a minute, something like that. So running it pretty safe, but yeah, I'd rather do that than wreck things, burn up end mills, that sort of thing. So it's kind of funny when you're running. I don't know, I don't have a ton of experience with running CNC machines. I've only ran Fadals. You can like turn in your feeds and speeds, and you can almost feel it in the machine, like where it's happiest, you know? Kind of get those vibrations and those noises. You can kind of dial it in where you feel like it's happy. So anyway, that's what we're doing right now. This is about an hour and a half run time on this roughing off. So so we'll check back in here after this is over, see how it looks. See how we look? Op 2. Looks pretty good. The surface finish on the inside's a little rough, but looks pretty good. All right. So now I gotta do one more. I gotta rough this out, this little bottom section here, and then we can start doing some of our finish passes. Get this thing all looking really nice. we go. I got that first side done. Had a little issue with the bullnose end mill that I used to do this fillet here. I'm having to use like a, I didn't have a carbide end mill long enough to reach and do this fillet, so I had to use an older kind of rusty high-speed steel, big 1.25 inch bullnose, and it worked great for like 3/4 of it, but then for some reason on the backside I don't know what happened there. All right, so I'm trying to think of what I want to do next. Do I chuck this other big chunk in here and do that next, or should I flip this over and kind of do op number 2? I kind of want to do op 2 and kind of finish this one, kind of make sure it's going to be good before I load the next one. So I think that's what I'm going to do. I think I'm going to flip this guy over, pick up my new work offset for it, and then machine that side, get that done, make sure everything's good. I hope I didn't ruin that bullnose end mill. I don't have any more in stock. So anyway, I think that's what I'm gonna do. I'm gonna flip this over, get the new work offset set up, and then machine the backside, and then we should have a finished, at least we'll have a finished piece. Tomorrow we'll load the next chunk in. So the next one will go a lot faster. You know, when you're machining something for the first time, like a new part for the first time, it takes a while to get all your feeds and speeds, get all your tool paths, getting everything in the right order, kind of getting all that sorted, you know. So plus when you have limited tooling, you have to be a little creative on how you do some things. So that's somewhat what happened with this, but I'm using a couple end mills that aren't really designed for cutting steel. They're more designed for cutting aluminum, but they're solid carbide, so they're working pretty good. Anyway, so that's what we're doing. So I'm gonna flip this over, pick up some new work offsets, and I'll get back with you. Well, that just happened. I don't know if you guys caught that in the time lapse, but I just threw the part out of the chuck. So the problem I'm having is, you can see the wall thickness is pretty thin. So, and I've got it in the chuck there or whatever, but it is, when I can't reef down on it because it's pretty thin and it's wanting to distort it a little bit. What I could do is put something in here. I mean, I could put a CV in here, but I hate to do that because I fear that I wouldn't be able to get it back out. So I don't think I hurt anything really. This is reality. This is how it goes sometimes. You gotta figure out you know, fixturing is 3/4 of the battle a lot of times when you're doing this stuff. Figuring out ways to. It's easy to hold the parts on the first op because you got a big chunk of stock. But once you got to flip it over and figure out a new way to hold it, that's when it gets tricky. So I'm gonna have to come up with a better solution here. So anyway, it's part of the process. I don't think I hurt anything on it, and I don't think I hurt my tool at all. It seems to be all right. Oh wait, did I? No, I think we're good. No, we're good. Tool's okay, but part's okay. Just my ego is the only thing wounded. Let's come up with a good solution here and we'll get back with you. All right guys, we have a part. So it's getting late, it's almost 11 o'clock, but I didn't want to stop until I had something done. So there it is. Finished part. Still need to chamfer the holes. I need to chamfer them and I need to tap 4 of them for the studs. And I need to get so I put the CD in there so when I clamped it, clamped the chuck on it, it wouldn't distort. Get a slide hammer here and get that CV pulled out, but that's it. That's the first hub piece. I'd like to weigh it, kind of see what it weighs. But so now basically I have this bearing. It slides down. So there'll be two of those bearings slid over. And then the upright, the aluminum upright will surround that. So it'll make more sense when I get, you know, some more parts made. So so I am going to tomorrow, if I can find the time, make the other one of these hubs. I'll make the other one, get those done, and then yeah, then we'll cut a big chunk of billet aluminum out and start machining the upright, and then we'll have some parts to actually start building off of. So, all right, guys, I'm gonna call it. It's late. We'll catch you probably tomorrow. Check that out. Perfect slip fit. Put a little grease on there. She is nice. So, pretty sweet. So I got it pretty close last night. I actually threw it out of the chuck. I tried clamping it on this thin wall, and it just didn't have, I think it actually distorted this a little bit. It just didn't have the clamping force when I was machining this side. I still need to go back and chamfer these holes here, and then I am gonna lighten it up a little bit. It's still a little heavy, so I want to be lighter than what the unit bearing and the other you know, the stub axle would be. So there's a lot of meat here that I don't need. I actually need to counterbore these for some bolts that are gonna go all the way through the CV. So I'm gonna counterbore. Well, I'm actually gonna just machine away, I think just a ring that'll be kind of like a counterbore. I'm also gonna bore out the center of the pilot. I don't need that. And just try to lose some weight on this thing. So as soon as I get this one dialed, then we throw the next chunk in the mill and start on the next one. But so far so good. This thing's turning out pretty good. It's kind of a lathe part made in a mill. It's pretty round. It's pretty true. Everything seems pretty good. All right, we got this thing pocketed out here. Show you what I got going on. You can see here I got rid of the center. I got the pockets cut here for the heads of the bolts, and also just getting rid of material. So I've got that all good going. So it's working on this first operation here, first tool path. So yeah, just hogging that out. Everything's going pretty good so far, and hopefully this will we'll lose some weight. So I'll get back with you when this op is done, and then we'll re-weigh this thing. I weighed it before this. It weighs 8 pounds, so we'll see what it weighs after we get this thing all pocketed out. All right, guys, let's wrap this one up. Lens is a little dirty. There we go. All right, so let's wrap this one up. You saw me going through all the different steps and stages on getting this hub machined. You can kind of see what goes into making a part, especially on a CNC machine. So I'm no expert at CNC machining. I'm kind of learning as I go here. Basically, all the parts that I've ever made on that machine have been kind of for my own use. I've done a little bit for customer stuff, something that I didn't go to school for, pretty much YouTube taught as far as running a CNC, really any machining goes in general. So anyway, this is the finished part. Got it all kind of machined, got my tolerances all good. These big bearings are a nice slip fit. The CV is also a pretty nice slip fit, which is what I was shooting for. And then I went ahead and I pocketed all this out. So you can see there, actually, you may catch it in the time lapse, but I threw this part out of the chuck twice. So, so I learned that when I'm running that 3-jaw, you know, that super spacer chuck, I gotta like crank down on those, on that thing to get it to hold, because it threw it out twice. So kind of embarrassing, but it's part of machining. It's kind of what you learn. This pocket was not supposed to be that deep. It's getting pretty thin over in these corners, but when it threw it out the second time, it kind of slowly was working its way out of the chuck, which was making the pocket on one of these deeper than it was supposed to be. And then eventually it did throw it out. So I went back and redid everything to that depth, so it'd all be the same. It doesn't really affect anything, doesn't really change much of the strength of the part. It actually lightens it up a little bit. And so it's okay. So on the next one, we'll get it figured out. So like I need 2 of these, so I need to make another one of these. But now that I have it all, now that it's all figured out, I've got the tool paths, everything kind of made and programmed. Now the second one should go a lot faster. And the ones after that, if I make more, I might make a couple more kind of while I have everything set up. I've got enough material over there to make a few more, so I might do that. So one cool thing about all this, like I talked about in the other videos, some of the advantages of doing what I'm trying to do. So with this, this part basically replaces these 2 parts here. So, you got your unit bearing here, and you got this stub axle, that the CV bolts to. So this part, so basically both of these weigh pretty much the same. I think this is 8.6 pounds, and these two are 8.6 pounds. So they weigh the same. I'll be honest, I was hoping that I could get this lighter than this. That was my original goal. But it turns out, I weighed them on my little scale. They weigh the same, which I'm okay with, because I'm still eliminating some parts here, and I'm also adding length to my control arms and my axle shaft. So, and I'm putting less angle in the CV. So it's still, the advantages outweigh the cons. So that's good. So this is still a better part than this whole stack up of parts. So that's good. So I'm probably adding, if I went the conventional path versus that way, I'm probably adding 8 inches, roughly 8 to 9 inches of length per side. So basically I'm adding like 12 to 16 inches overall. I can lengthen the A-arms, and I can lengthen the axle probably 12 to 16 inches. So I can have the same track width, the overall width of the cart, or the whatever you want to call it, the cross cart. I can have the same track width, but I can lengthen everything within that track width. So it's going to be, so I can have long travel and less angle on all the parts, which is going to be sweet. And it'll also handle better. It's going to handle better. Anytime you can lengthen suspension geometry, you slow down the motion of all those components, which makes it handle way better. If you can get things level and long, you're basically, for example, I grew up in Minnesota, right? So in the wintertime, we drove no matter what. It was snow on the road, whatever. But anyway, what I'm getting at is, in the wintertime, I remember my dad had a crew cab, long bed Chevy truck, 2-wheel drive. And I remember that thing, you could get it in the parking lot, and you could drift it, do cookies in the parking lot, and you could hold that thing out as long as you wanted. And it was super controllable. It was super long truck, and you could let it hang out there, and you could just drift it around, and it was so predictable. Versus, I had a CJ5 Jeep, and you couldn't drift that thing if you tried. It was so short, and the wheelbase was so short that it was just spinning, and everything was happening so fast that you couldn't control it. So it's kind of, I guess what I'm trying to get at is, when you have something that's long, when you can lengthen something, it slows it down and it creates more control over everything. I hope that makes sense. Kind of a silly analogy, and I'm not an engineer, but it's kind of gets your mind wrapped around the thought behind what I'm trying to do here. So it'll slow down everything. It's gonna diminish the angles of parts, and it's gonna make everything happy. So and at the end of the day, it's fun to build this stuff. That's really what it boils down to. It's fun making something different, unique, something you've never done before. So anyway, with all that being said, I think I'm gonna end the video here. Next video would be probably, I think I'll make the other hub. I think I'll make that one off camera. And then the next part we make probably will be the billet aluminum upright that this hub and bearings and everything will be inside of. So that'll be the next part. So that'll be a bunch of aluminum, which aluminum is a lot easier to machine than steel. So anyway, that's it. All right, guys, catch you on the next one. See ya.